in the Mavic package study, and she actually tried to group a small cell lung cancer based on the microRNA expression, and that seems to be, and the expression of certain microRNA may correlate with sensitivity to a particular type of a drug. So that seems to be the case. Okay, well, we'll be going further to our tour. Come out in the hallway. Thank you so much. Okay, we're going to get started. Dave Wink is going to be talking about biochemistry of redox species. But he's coming down from Frederick. I think they have run into a little traffic on I-27. So we're going to start with Stefan. And Stefan is a senior investigator in the Laboratory of Human Carcinogenesis. He's at the Molecular Epidemiology section. And you'll see from his accent that he was educated in Germany. And he got his PhD in 1992 from the University of Würzburg. Subsequently, he came to MCI, and he's been a tenure track investigator since 2001. He was tenured in 2010. The title of his talk, Contribution of Oxidative Stress to Human Cancer, Evidence for Cancer Epidemiology. Stefan. Thank you so much for the introduction. Thank you for coming. So, yeah, I will look at the relationship between oxidative stress and cancer development from a kind of a different angle, from a laboratory standpoint for more. What evidence do we get out when studying the population? And when studying the population, we usually can study mechanism. So what we're going to do is we look at exposure and association with disease. And I want to tell you what kind of evidence do we have out of a population study. The oxidative stress is very important in disease development. While we do not have mechanism, and you cannot really conclusively link exposure to a disease development out of epidemiology, you can always have confounding kind of an observation. It's still very important to have evidence from epidemiology. When we do experiments with cell culture with animals, we get beautiful results. We have something, soil of a cell, we transform the cell gets more present, we do it with animals, we get to do what the old man. This is a really important compounding called standard. And then usually after we see those initial observations, epidemiologists get interested and say, okay, let's study the population if we can. We cannot always. But sometimes we can very well. And they say, okay, how is it into disease? And I should go see it. And this may have something to do with that is no linkage. Second, it may have something to do with the population to look at the population. This was not achieved, so that is not an important link. And, what it tries to do so much in the laboratory for human disease, that's just not so important. This could be the point further about the research. But it's really important for society to know those kind of things. Because there's a limited amount of money, and we have the money we have to use to have to make our decisions how we communicate with the population and how we try to protect it by protecting the population. Otherwise it's going to get the best take out power. Okay, good. So what is the evidence that oxidative stress is linked to cancer? I will go through a little bit of introduction. Is here are the hallmarks of cancer as it was described between Oppenheimer and Weinberg, I don't know, 10 years ago. They had these kind of hallmarks that is common to most cancer. And these are kind of schematic was modified several times. Here it was modified in 2009, and they added new hallmarks to it. And one hallmark that was added is now oxidative stress, saying that the production of reactive oxygen is usually having cancer. And one important mechanism of that is that you get DNA damage. It can be up in a pre-cancerous lesion and it leads to cancer, or it can be up in cancer and it leads to cancer progression. So it's very important, and at least out of experimental systems. And then there's a question, how is it important in the population? What